So yeah, this is the second question. Find the z transform of cos h n theta and sin h n theta. So now what is this h? This h is an hyperbolic function. You might have heard this in your previous semesters. And hyperbolic trigonometric functions. So this question is there, right? This is a very important question. So you please make a note of this question. This can be asked in your exams. So yeah, please make a note of this, and this is a very important question. So in order to find the z transform of these functions, we need to know what are the values for cos hyperbolic and sin hyperbolic functions. So now first we'll write that. Some of you might be knowing it. I'll write it. The cos h n theta is given by e to the power n theta plus e to the power minus n theta divided by 2. Please put this in a box. This is a very important formula. Similarly, sine hyperbolic function is given as e to the power n theta minus e to the power minus n theta divided by 2. Please make a note of these cos and sine hyperbolic functions. After this, we need to find the z transform of these functions. Okay, so now let's solve this. Yeah, so now let's solve this z transform. So here we can take some common terms outside. That is, this 2 is there, right? So it becomes 1 by 2. We can take this 1 by 2 outside, and we can use the first property, that is the linear property. That is, we can add the z transform. We can split the z transform inside. So how does this become? Z transform of e power n theta plus z transform of e power minus n theta. This is by using the linear property. Again now, by seeing this e power n theta term, we can remember of another one z transform general formula we have discussed, that is z transform of e power an. So this is given as, we have discussed it, z divided by z minus e power a. So the same thing we are going to apply here as well. So in place of a, that is, we have theta. So wherever a is there, right, we need to replace it by theta. So now what does this become? It becomes z transform of e power n theta is given by z divided by z minus e power a, right? In place of a there is theta, so we need to write theta plus z divided by z minus e to the power, so n into minus theta, right? So the e power minus theta. In place of a we need to write it as minus. So that's it. Now we need to just simplify these terms. That's it. In order to reach the final answer, we need to simplify. So now just cross multiply and take the LCM. That is, we need to cross multiply minus e power minus theta plus z into e power theta divided by, we need to multiply these two, that is so again now multiply these two terms. Z into z is z square minus z into e power minus theta plus z into z again z square plus into minus minus z e power theta divided by, again we need to multiply these two, z into z z square minus z e power minus theta minus z into e power theta. I'm just multiplying it. Minus into minus is plus e power theta into e power minus theta. So now add, there are two z terms, so it becomes 2z square minus, in these two terms this z is there, right? Minus z is common, right? So I am taking it out. I am writing the remaining terms, that is e power theta plus e power minus theta. I took minus z common outside. divided by z square minus z e power minus theta minus z e power theta, and this can be replaced by, so let's, by simplifying this, what we get, so I'll do it here, e power theta into e power minus theta. So bring this e power minus theta to the denominator. So what does it become? E power theta divided by e power theta. I brought this, we know that e power minus theta is equal to 1 by e power theta, right? So that's all I did, and we can cancel it and make it as 1. So I'll directly write it as plus 1. Okay. So now this is not it, we need to further simplify it. So if we observe this term carefully, so we can conclude, we can say that e power theta plus e power minus theta, this is similar to an hyperbolic function. In order to complete the hyperbolic function, we need divided by 2, right? Cos h of n theta is there, but here there is only theta, so we need to get the cos h of theta. So for that we need this divided by 2, right? So now let's bring that divided by 2 by multiplying and dividing by 2 for this term. That is 2z square remains as it is, minus, we need to multiply 2 here, into e power theta plus e power minus theta divided by 2. Okay, divided by the same term z square, and again in the denominator we can take z common, see that minus z we can take it common, and we can multiply 2 as well there to get the hyperbolic function, that is e power theta minus e power plus e power minus theta divided by 2 plus 1. So we are just doing this multiplying and dividing by 2 for the sake that we need to get an hyperbolic function, so that we can directly write the hyperbolic function. Okay. So by further simplifying, what we get, minus 2z into, so this corresponds to an hyperbolic function, that is there is plus, right? So cos h into in power of e power, that is there is only theta. In case of cos h n theta, right, this n theta, that is the power of e, right? That only we are writing it. So here also we need to write the power of e. What is the power of e here? That is theta. So cos h theta divided by z square minus 2z, again there is plus, so cos h theta plus 1. So again in the numerator we can see that there 2 is common, right? Take that 2 outside and write the remaining terms, z cos h theta, z square minus 2z cos h theta plus 1, and cancel this 2. So this is the required z transform of cos h n theta. So just see this whole sum again carefully. See all the steps clearly. I have done the problem by step. Otherwise this problem is generally completed by 4 or 5 steps. I have done this in brief and in an easy manner so that you can understand. Similarly we are going to do it for sin h n theta. So now we are going to do it for sin h n theta. The formula for sin h n theta is given by, there is no change at all. In case of sin, in place of plus we need to write it as minus. And now again I have taken 1 by 2 outside and I have splitted the z transform by using the linear property, and in last problem there was plus, so now it become minus. So now again we need to use the z transform of e power a n, where in place of a there is theta. So the same thing we are going to do it again. We are going to get it as z divided by z minus e power theta. So now minus z divided by z by e power minus theta. So the same thing we need to simplify this. I'm going to do it quickly now. cross multiply e power minus theta minus z divided by e power theta divided by minus theta. Multiply the terms z square minus z e power minus theta minus z square plus z e power minus theta, minus into minus plus z square minus z e power minus theta minus z e power theta plus e power minus theta. So you can see that z square gets cancelled, and we can take z common. If we take z common, what are the terms remaining? E power theta minus, we took z common. In the last problem we took minus z common, right? So this minus we need to include in the bracket, divided by z square. Again we need to take z common in these two terms. Now minus z we can take it common, and we can write it as e power theta plus e power minus theta plus 1. This term becomes 1. So now again we need to multiply and divide by 2 for these both cases in order to get a hyperbolic function. E power theta minus e power minus theta divided by 2 z square minus 2z into e power theta plus e power minus theta divided by 2 plus 1. So this corresponds to a sine hyperbolic function, since there is a minus. So sine h of e power theta, right, divided by, and this there is a plus, so this is a cos h of theta plus 1. So again we can cancel this 2, and the final answer is cos h theta plus 1. So these cos h theta and sin h n theta hyperbolic functions which we have solved, you need to remember this. So make a side note of it, okay? So yeah, please make a note of these z transforms, because these z transforms again can be used in further many problems for solving, okay? Please make a note of these z transforms. Z inverse of z square plus z divided by z cube plus 6z square plus 11z plus 6. So now let's solve this. So now this is of the form, this is not of the form of partial fraction, as we have solved one problem related to that, right? So for this we need to take the synthetic division, okay? So now let's apply the synthetic division. Let's apply the synthetic division. Let's take the coefficients of this term, that is 1, 6, 11 and 6. So the first root, we need to write it here. The first root is that whatever we need to fill the z value such a way that the answer we get is 0. So I've already done that. So you need to put this equation in the calculator, and you need to find the root, first root. So the first root which I got is -1, okay? So now nothing much to do. This 1 you should bring down, then multiply -1 with this term, that is -1 into 1 is -1. 6, we need to add these two terms, that is 6 plus 1, so 6 minus 1, so it is 5. -1 into 5 is -5. 11 minus 5 is again 6. -1 into 6 is -6. So this term, the last term which we got is 0. Okay, this we need to get, we should get this last term as 0 always. So now with these terms, let's write the quadratic equation, that is z square plus 5z plus 6 is equal to 0. So now again we need to find the other two roots by using the quadratic formula, okay? So now let's use the quadratic formula. As we know that the quadratic formula is minus b plus or minus b square minus 4ac the whole root by 2a. So we'll apply that. Here the value of b here is 5, right? So minus 5 plus or minus square root of 5 minus 5 square is 25 minus 4 into 6 into 1, that is 24, divided by 2 into 1, that is 2. Okay, minus 5 plus or minus 1, square root of 25 minus 24 is 1 and square root of 1 is 1, 2. So z equal to minus 5 plus 1 by 2 or minus 5 minus 1 by 2. So the value of z we get is this is minus 5 plus 1 is minus 4 by 2, that is minus 2, comma minus 6 by 2, that is minus 3. Okay, so the finally we get these three roots, that is minus 1, minus 2 and minus 3. So the following z inverse with the question would be looking like z plus 1. Since the root which we got is minus 1, right? So always we need to write it as z plus 1, z plus 2 and z plus 3. Okay, so these are the three roots which we got. So now in this we need to simplify this term using the partial fraction. So now let's solve it. So we know that the equation would be a z divided by z plus 1. Since the power is 1, right, so we need to multiply the numerator by z plus bz by z plus 2 plus cz by z plus 3. Okay, so now in order to cancel these terms we need to take the LCM. So the LCM, by taking LCM, the term which we get is z plus 1, z plus 2, z plus 3. So these are the terms which we get, because by taking the LCM there is only z plus 1, right, but we need other two terms. So which are the missing terms here? Z plus 2 and z plus 3. So we need to multiply that. The same thing here, z plus 2 is there, we need to multiply z plus 1 and z plus 3. Same goes with cz. Okay, so now the remaining terms are z square plus z equal to az into z plus 2, z plus 3, bz into z plus 1, z plus 3, cz into z plus 1 and z plus 2. So now here we can see that we can take z common, right, in both LHS and RHS. So we will take that out so that we can cancel that z. So the remaining term here is z plus 1 equals to z into a z plus 2, z plus 3 plus b z plus 1, z plus 3, z plus 2. So here again we can cancel this z, so the final equation which we get is z plus 3, b z plus 1, z plus 3, c z plus 1, z plus 2. So this is your required equation. So take this as equation star, this as 1. Okay, so now we know that we need to find the values for a, b and c. So we can find, this is a straightforward question. We don't need to compare any coefficients. So to find the value of a, we need to make these two terms equal to 0, and which is a term common in these two terms, that is z plus 1, right? And here in order to make this two terms equal to 0, we need to substitute the value of z as minus 1, so that this becomes 0, and also here also minus 1. So in the first case, in order to find the value of a, we need to put the value of z as minus 1. Okay, so I have substituted the value of z as minus 1. So we know that this will become b into minus 1 plus 3 plus c into minus 1 plus 1 minus 1 plus 2. Here also we can cancel these two terms, because minus 1 plus 1 is 0 and 0 into these both terms also become 0. Same goes with this. So the remaining term is, this becomes 0, a into minus 1 plus 2 is plus 1 and minus 1 plus 3 is plus 2. So the 0 equal to 2a. So therefore the value of a which we get here is 0. Similarly, find the values for b and c. In order to find the value of b, we need to put the value of z equal to minus 2. Okay. So the following equation becomes minus 2 plus 1 equal to a into minus 2 plus 3 minus 3 plus 3 plus b into minus 2 plus 1 minus 2 plus 3 plus c into minus 2 plus 1 into minus 2 plus 2. So this is equal to 2, okay. So now we can cancel these two terms because minus 2 plus 2 is 0 in both the cases here. So the remaining term is minus 2 plus 1 is minus 1. B into minus 2 plus 1 is again minus 1. Minus 2 plus 3 is 1. So minus 1 equal to b into minus 1 into 1 is minus 1. Therefore the value of b equal to 1. Since minus b equal to minus 1, so we can write it b equal to 1. Okay. So similarly find the value for c. To find the value of c, again we need to put the value of z as minus 3. So the equation is minus 3 plus 2 plus b into minus 3 plus 1 minus 3 plus 3 plus c into minus 3 plus 1 into minus 3 plus 2. So we can cancel these two terms because minus 3 plus 3 is 0, right? So minus 3 plus 1 is minus 2. C into minus 3 plus 1 is again minus 2. Minus 3 plus 2 is minus 1. Minus 2 equal to c into minus 2 into minus 1 is plus 2. So minus 2 equal to 2c. Therefore the value of c which we get here is minus 1. So we got the values for a, b and c. So now substitute it in equation star. So here I have substituted the value of a, b and c. So now we need to take z transform as a inverse z on both sides so that we can get the z inverse. Z inverse of this term we can neglect it, we can write it as 0 because 0 is there, right? So let's start with this term itself. Z inverse of z by z plus 2. This 1 I have taken outside here, you can write it as 1 minus 1 into z inverse of, so z inverse of z by z plus 3. Okay, now we know that it's of the form z by z minus a. So in place of here it is z plus 2. So this can also be written as z minus of minus 2. Here also z minus of minus 3. So here we can say that the value of a here is minus 2. So the answer is minus 2 power n minus of minus 3 power n. So this is a required z transform.